Hi, hello friends. Welcome to T Academy. In this session, we will continue our power system important short notes or formulas. This is the third part of this lecture. So we already covered two parts in our previous session. So hope you liked that video and you have seen that video. Okay, if you like the video, please subscribe to my channel and it will motivate us to do more and more for you. Okay, so without wasting our time, we'll move to the topic here. So in the economic aspects of power system, so first for most important definitions we'll discuss whether it's important for examination point of view if you understand the concept here. So first one it is we'll talk about the connected load. Okay, so what is this connected load? So connected load can also be known as installed capacity. It is known as installed capacity. What is it? What is going to do is it, sir? It is the sum of arithmetic. It is arithmetic sum of all the electrical equipment together. So it is what? Arithmetic sum of all the electrical equipments ratings. Okay, for example, if you are having in your home, the basic things are television will be there, computer will be there, and there will be a fan or AC, etc. So all these ratings of this component will give you a connected load or installed capacity. Okay, so we'll see the next definition. That's a very important here. And maximum demand. So maximum demand here. So what is maximum demand is say about is highest amount of power consumed by consumer. So highest amount of power consumed by consumer. For example, among the what you have discussed, TV, computer, fan, etc. are there, na? So among them generally we can use a TV and fan for general purposes. Okay, so if these two are only you are using, that will be your maximum demand. Okay, now next definition is we'll talk about demand factor. So demand factor. So demand factor is nothing but it is a ratio of maximum demand to the connected load. It is a ratio of maximum demand to the connected load. So which is always less than 1, as you know. And next one is here load factor. So what is a load factor? So before going to discuss the load factor, we will discuss about average load. What is this average load here? Okay, so average load or average demand. So what does it say about is it is the amount of energy consumed by the consumer over a specific period of time. Okay, remember here it is the amount of energy consumed. So I can say energy consumed by the consumer over a specific period of time. So specific period of time means the period of time may be an hour, or it may be a day, or it may be a month, okay, or it may be a year. Okay, so next formula we'll talk about it is a load factor. So load factor, so important formula here, remember this load factor. It is defined as it is a ratio of average demand, so average demand or average load to the maximum demand or maximum load, so which is also less than 1. So average demand already you know what is that. It is energy consumed by the consumer over a specific period of time. So if you write this one, what you can write? So energy consumed by consumer, okay, so sorry for my handwriting, divided by so specific period of time. So specific period of time into maximum demand. So there is another formula which you can use here. Now what is the advantage of this load factor? So it should be less than 1, but the load factor should be nearer to approximately equal to unity. Okay, what is the advantage of this one is it is going to, if the load factor is approximately equal to 1, it is says that it will reduces running cost. So running cost of the power plant. Okay, so there is the advantage of this load factor here. Next one, it is diversity factor. Okay, sorry. Next we'll talk about diversity. So diversity factor. So diversity factor defined as it is the arithmetic sum of maximum loads of all divided by maximum demand on power system. So defined as maximum demand, arithmetic sum of all the individual maximum demands, to the maximum demand on the power system. So maximum demand on power system. So this max diversity factor is always greater than 1 here. Okay, so it is the only factor which is always greater than here. Okay, so it is going to reduce the fixed cost of the system. So it's going to reduce advantage here. It reduces fixed cost of the power plant. Okay, and next one here, it is the plant capacity factor. So plant capacity factor, so it is also known as capacity factor, which is defined as it is the average load divided by installed capacity, or it is also known as plant capacity. Okay, it's an important formula here. And similarly, plant use factor is there. So plant use factor, so it is a maximum demand, by installed capacity here. Okay, there is one more formula which may occur in examination point of view. It is reserve capacity. So important, this one also, reserve capacity. So reserve capacity, it is a difference between the installed capacity minus plant capacity. Okay, so here examination point of view, they won't give directly installed capacity and plant capacity. So there you need to use this above formulas here for doing calculations point of view. Okay, so next we will discuss about the power system protection. Next, in power system protection, system is lighting arrestor. LA is nothing but here LIGHTNING, lightning arrestor. So lighting arrestor are the first and also the last protecting devices against surges. Okay, so if you enter into the substation, there will be first thing you can see is there will be a capacitor bank is there. Generally in substations, normal substations, there is a distribution substations. There you can see the lighting arrestors will be placed there itself. Okay, and if you are seeing other side of the substation, there is a feeders are there, incoming feeder, outgoing feeder. The feeder is also connected with lighting arrestors are there, nearby devices are there. Okay, it is used to give protection against surging strokes. Okay, and it is made up of zinc oxide. So zinc oxide is having a property of negative resistance. Generally during normal operating conditions, normal healthy conditions, it will offer high amount of resistance. So high amount of resistance to voltage and current. Okay, high. And then during abnormal conditions, whenever surge strikes, automatically its resistance going to be low, so that it will allow a path for the surges. Okay, so it is made up of zinc oxide, silicon carbide and thyrite, and have a impulse ratio. What is the impulse ratio? It's also an important formula. Impulse ratio is nothing but it's a breakdown voltage of the wave of specific frequency divided by the breakdown voltage of 50 hertz wave. Okay, and this is the impulse ratio, and this impulse ratio is of different value for different insulators here. For example, it is 1.4 for a pin type insulator and it is 1.3 for suspension type insulators. Next point here, it is see. So CVT, there is nothing but a capacitor voltage transformer. So generally you have seen voltage transformer, generally transformers. Here capacitor voltage transformer, it is used to provide higher voltages to the system. Okay, next one it is CT. CT is nothing but current transformer. So current transformer consisting of single turns, a single primary turn and multiple turn secondaries connected to the wattmeter. Okay, ammeter and differential relays here. Generally whenever you see the line here, it is having a single turn, means just like one turn here. Okay, one turn, and secondary will be a straight line like this and a single turn here. Okay, we'll move to the next point here, right? And next one here, from the power system protection point of view, right? Isolator. So isolator is nothing but it's just like a mechanical switch. That is, generally we have seen, suppose if you see the substation tower here. Okay, in tower there is a open contacts like this. Okay, where we have a switch like this. So this can be mechanically operated with the help of a plunger here. Okay, so when you drag that plunger, it will closes. Okay, there is no arc quenching mechanism here. That means there is nothing to make the arc quenching medium here. Generally in case of circuit breakers, we have SF6 circuit breakers or oil circuit breakers. Some mechanism will be there to quench the arcing, but in isolator it will not have. So because of that reason, okay, it is only operated at no load conditions. Important, keep this point in your mind. Okay, it is operated only when there is no load on that line. Okay, what will happen if you open that line? Simply, if you open that line during its loaded condition, the dielectric medium of air acts as a capacitor, so there will be a huge spark occur between these two contacts, so that we will not properly isolate the substation equipments. So isolator is always used under no load condition only. Remember this point. Next one here, earth switch is there. So earth switch is used to discharge the residual energy. So why this residual energy will be there, sir? So generally our power system components made up of especially L and C. We can neglect the R. L and C are there. So these two are the energy storage elements. So mostly inductance in nature. Okay, whenever if you want to open a transformer for a service purpose or maintenance purpose, first you need to close the earth switch here. Okay, so once you close the earth switch, whatever the energy stored in the inductor, it will going to be grounded. Okay, if it not, means suppose if you are going to touch that part, then it will be harmful to the person who is operating. Okay, so that is why earth switch is a mandatory. So earth switch is used to discharge the residual energy. Next one, wave trap is there. So wave trap is used for communication purpose. So if it is used for communication purpose, nowadays we are reaching a SCADA technology. Wave trap, what it will do is, along with the power signals from the one substation to other substation. Okay, suppose one substation is here, another substation is here, second substation, we can send the communication signals. That means the operating personnel in the substation 1 can talk to the operating personnel in the second substation by using this wave trap here. Along with this wave trap, what we can do is, in some areas we can control the other substation voltages also. Okay, there's advantage of this wave trap here. So all these things will be available in a SCADA systems. Next one, this point is regarding to our SF6 circuit breakers. So lockout or struck breaker. So struck breaker means is a condition when the SF6 circuit breaker SF6 pressure is lesser than the required. That means normally what will happen is, especially in SF6 circuit breakers, the gas is going to be leaked out. That means some part of the gas is going to be leaked out from the some corners of the circuit breaker device. So what will happen is, when the fault condition occurs, the circuit breaker may not able to quench the arc. Okay, that condition you can call it a lockout or struck breaker condition. Okay, so not to operate even under the fault conditions. Okay, it's not working properly. So under normal conditions, the circuit breaker blocks means, so blocking means, so TC means trip. Okay, when is going to trip? Whenever the fault is there, the circuit breaker is going to trip. Otherwise it is in normal close contact. Why? Because circuit breaker is the element which carry the actual current. Okay, which will carry the actual load current here. So it is in always closed position. Whenever the fault will be there, it is going to be opened up. Now IDMT. So IDMT means inverse definite minimum time. Inverse definite minimum time takes less time to operate. As the name itself indicates, inverse time means fault current is higher, means it will take lesser time. Okay, what will happen, sir, if not, means what will happen? Fault current is higher means it will causes I square R losses, so it will be more amount of energy dissipated, so it may causes fire also. Okay, and very inverse time means it will operate in very lesser time. That means extreme inverse means very less amount of time. So these all are depends upon when it depends upon the fault current. Fault current higher means the operating time will be very less. Okay, next one here. It is from the relay. Instantaneous relay operates at a certain fault current. That means generally instantaneous relay what will do is it will carry a normal amount of current. Suppose 5 amperes it's a normally amount of current carrying. Now suppose we got a 5.5 amperes of current. Now what will happen instantaneously after exceeding this threshold value of 5 amperes, generally it will operate. Okay, generally instantaneous relay operate when it means during the rainy season or during the heavy winds. What will happen is the tree branches nearer to the power conductors is going to be swing. So when they are coming to contact, at that time instantaneous relay will operate. Generally practically it will not happen, it will have some time of operation practically, right? But ideally speaking or theoretically instantaneous relay will operate whenever the fault current exceeds a predefined value or threshold value. And next point here, it is electromagnetic attraction relay. So electromagnetic attraction relay is not used. Why? Because it's a doubling effect. What will happen doubling effect is it's just like a spring action. So okay, in electromagnetic attraction type, when the moving part and fixed part, they come into contact with each other. So what will happen here is there is a torque is produced. The torque will have two components. The first component is positive, second will be negative component. So because of this doubling effect, that means it will have both positive torque and negative torque. It will vibrate, oscillate. So when it's oscillate, what will happen? The arc quenching may not be properly. Why? Because circuit breaker open means the contacts has to be separated. But what is happening? The contacts are going to again touch and open like that. That's what we can call as a doubling effect. So which we will not use ideally. Okay, it will electromagnetic attraction relays are good for DC power supply but not for AC power supplies. Okay, and the next one, electromagnetic induction relays is independent of frequency. Electromagnetic induction relays are independent of frequency. Next one, watt hour meter relay. So watt hour meter relay is a non-directional current relay. So non-directional means it won't bother about the direction of current, whether it is flowing from generating station to the load or load to the generating station. So in this case we can say TD, deflection torque TD is equal to phi m1 into phi m2 into sin theta here. Okay, so generally if phi m1 and phi m2, if we say same current means, so IF square into sin theta here. Okay, so what will happen when the switch is going to trip means whatever the deflection torque is more than the restraining torque. Restraining torque here means nothing but a spring here generally. Okay, so spring, then it's going to be operate, otherwise it's not going to be operate. We can say it's a threshold value simply generally. Okay, next one, very important formula, most of the students will confuse here. Remember this point, pickup current. So pickup current is defined as it is a ratio of, it is defined as IPK is equal to current transformer secondary current, that means actual current. So current transformer secondary current into plug setting box setting value. Okay, so PS value or plug setting box value. Okay, if they are not given, we can assume it as a 100% here. Now the PSM, plug setting multiplier. So don't confuse this plug setting box and plug setting multiplier. So plug setting multiplier is equal to, it is a ratio of fault current. So fault current, it is actually in amps. So fault current in amps divided by IPK already studied. What is IPK? IPK is nothing but it is the CT secondary current into PSB value into CT ratio here, into CT ratio. Okay, next one here, the time of operation of any relay is nothing but the time setting multiplier TSM into the time from IDMT corresponding to PSM value. There is a table is there, in the table column we can take this time from the IDMT corresponding to PSM. Okay, and next we'll see the time of operation of backup relay. So time of operation of backup relay is equal to the T delay, there is a time for delay plus the time for primary relay here. That means what is the meaning here? Suppose whenever a fault occurs in substation 1, there is another substation is there as a backup here. So the relays are there for this substation and this substation, both are there. Whenever the substation 1 fails to operate its fault, then substation 2 will going to be operate here. So that is nothing but a time of operation of backup relay. Okay, so second substation will act as a backup for the substation 1. Okay, so time delay in the substation plus time plus here, so time of time primary relay. Next one, CD ratio is defined as secondary by 1 means actually whatever the ratio secondary given, you can consider as a secondary value, divided by 1 means generally 1 as a primary terms. Okay, if not given any specified values here. Okay, so thank you friends, thanks for watching my video. We'll continue in the next coming session. Have a nice day, take care, bye bye.